Hi students, now we are going to explain what is Avogadro'S hypothesis or Avogadro'S principle. Now the statement of Avogadro'S hypothesis is like this: at constant temperature and pressure, equal volumes of all gases contain equal number of molecules. Okay, so let us prove this statement. So for that I have considered the two gases and the pressure exerted by the two gases expression I have written. So the pressure P is equal to 1 by 3 into Nm V square average. This suffix 1 is for the first gas. So small n1 is the number density, small m1 is the mass of one molecule, and V1 square average, that is the square, mean square velocity. Okay, like that. Here the pressure P equal to 1 by 3 into N2 M2 V2 square. Number density N2, mass of the molecule is M2, and mean square velocity of the second gas is V square bar 2. Now I have not written the subscripts P1 and P2 because here it is constant pressure. So the pressure is constant. So P1 is equal to P2. So I will write the expressions like this: P is equal to 1 by 3. This number density is total number of molecules N1 by volume V into M1 V1 square average. Like that, here P equal to 1 by 3 N2 by V, where capital N2 is the total number of molecules, and M2 V2 square as we have stated earlier. Now it is very clear that pressure also is kept constant, is it not? So I am going to equate these two. And volume also is a constant, equal volumes is mentioned. Therefore, this V1 and V2 subscript I have not used. So equating the pressures 1 by 3 N1 by V M1 V1 square is equal to 1 by 3 N2 by V M2 V2 square bar. So cancelling 1 by 3 on both sides and this V on both sides, I get N1 into M1 V1 square bar is equal to N2 into M2 V2 square bar. This is the equation 1. Next, here temperature also is kept constant. So at constant temperature, the average kinetic energy per molecule must be a constant, isn't it? Therefore, half M1 V1 square average is equal to half M2 V2 square average. Cancelling half on both sides, M1 V1 square bar is equal to M2 V2 square bar. This is equation 2. Now the second equation is substituted in the first equation so that these two get cancelled. Therefore, I get N1 is equal to N2. So N1 is equal to N2. What do you mean by that? The number of molecules of the first gas is also equal to the number of molecules of the second gas. So we have proved that at constant temperature and pressure, equal volumes of two gases we have shown, they will have equal number of molecules. This is only Avogadro's hypothesis or Avogadro's principle. I hope you must have understood well. Fine.